Right. Good afternoon, students. So, in the last class, we have finished till question number 13. So, let us quickly revise what we have done so far in this chapter. Okay. So, in this exercise, we have learned about how to find the slope of tangent, how to find the slope of normal. So, when a curve is given to us, y is equal to something. If you're asked to find the slope of tangent, then you have to differentiate with respect to x. dy by dx is the slope of tangent. Okay, and what is slope of normal? Minus 1 divided by dy by dx. Whatever you got in the value for dy by dx, when you find the slope of normal, it will be minus 1 divided by dy by dx. Slope of tangent and slope of normal. We also learn about how to find the points on the curve. How to find the points on the curve when slope is given to us. Okay, now from question number 14 onwards, now what type of questions will I be getting? Now the questions from number 14 onwards will be find the equation of a tangent and find the equation of a normal. So that's going to be the question from number 14 onwards. Okay, find the equation of a tangent and find the equation of normal. Now for our understanding, let us look at this graph. This is x-axis, this is y-axis. Randomly I have taken a curve. So this is a curve which will be given to us. Curve given to us. This is my fx, which is my curve. Now at this point, on this curve, at this point P, I am drawing a tangent. Okay. So in the previous exercise we used to find just the slope of tangent, and normal means a line which is perpendicular to this tangent, isn't it? But now not only with the slope, but we also have to find its equation of this tangent. We need to find equation of this tangent, and don't forget that this tangent is also straight line. So equation of a tangent will be similar to equation of straight line. Okay, and we have done in class 10 to find the equation of straight line, isn't it? The equation of straight line having slope m will be y minus y1 is equals to m x minus x1. The similar kind of equation will also be here in our case. So hence we now start with the formula for equation of tangent. So equation of a tangent at point x1 comma y1, point P, coordinates x1 comma y1 is given by, equation of tangent is given by the same formula that we have done in class 10. Okay, y minus y1 is equals to dy by dx x minus x1. dy by dx is the slope. So just the value for slope has been changed. In class 10 we used to learn slope as m and tan theta, but here since we are doing differentiation, this particular chapter is application of derivatives, isn't it? So there has to be dy by dx. Hence the equation of tangent goes like this. Y minus y1 is equals to slope x minus x1. Slope of tangent. Okay. And if you ask to find the equation of normal at the same point x1 comma y1, the formula goes like this. Y minus y1 is equals to, this is the slope of normal, isn't it? Minus 1 divided by slope of tangent into x minus x1. So slope of tangent, slope of normal. So remember that it's starting with y minus y1, y minus y1, x minus x1, x minus x1. If it is tangent, slope of tangent. If it is normal, slope of normal. Okay, so pause the video to note down. So now using these two formulas, slope of tangent, equation of a tangent and equation of normal, we will proceed our exercise with question number 14. The question is, find the equation of a tangent and normal to each of the following curves at the given point. Okay, so each of the following curves. So the first curve given to us is y is equals to x cube. So this is the given curve, and I need to find the slope of the tangent on this curve. Equation of a tangent on this curve at point 1 comma 1. So I'll start with slope. dy by dx 3x square. So slope of tangent at which point? 1 comma 1. So put the value for x equals to 1 since there's no y term. So dy by dx is equals to 3. So this is the slope of tangent. Clear? Now slope of normal will be just the opposite sign with a minus sign, isn't it? So minus 1 by 3. Okay. Now what we need to do? We need to find the equation of a tangent and normal. So first we'll start with equation of a tangent. Equation of a tangent at 1 comma 1. Use the formula y minus y1 into dy by dx is equals to x minus x1. So y minus y1 we are finding at point 1 comma 1. So this is the value for y1. dy by dx we know, and x1. Okay, so simplify it. We will be getting equation of a tangent as y is equals to 3x minus 2. Okay, and with the same values now we find equation of normal. So equation of a normal will be like this. Equation of normal. So equation of normal at which point? Equation of normal at 1, 1. Again, the formula is y minus y1 is equals to 1 divided by dy by dx. You know the change. When it's normal, you know the change. X minus x1. So put the values. X1 is 1, y1 is 1. We know the value for minus 1 divided by dy by dx. Slope of normal, isn't it? Minus 1 by 3. Slope of normal is minus 1 by 3. So we put the value out here. Slope of normal, that is out here. Okay, evaluate, simplified, you'll get the equation of a normal as well. So pause the video for the okay, 14 part 1 I've done, part 2, part 3 and part 4 are similar. I'm straight away jumping to number 14 part 5. Okay, y is equals to sine square x, trigonometric function given to us, and we need to find the equation of a tangent at x is equals to pi by 2 and equation of normal at x equals to pi by 2. So we start with the slope first. So dy by dx, you know how to differentiate. 2 sine x cos x. Now the formula is sine 2x. So therefore slope at x equals to pi by 2. If you put the value x equals to pi by 2, 2 and 2 gets cancelled out. Sine pi means 0. Sine 0 is 0. Sorry, sine pi is 0 straight away. So hence the slope is also 0. Okay, slope of what? Tangent. So slope of tangent is dy by dx, isn't it? So dy by dx equals to 0. This is the slope of tangent, which is 0. Now I'm not finding the slope of normal right now. I'll tell you the reason why. Okay, when we find equation of normal, we'll find the slope of normal also. Okay, so first we start with slope of tangent. So if the slope of tangent is 0, then see, I don't know the point. I only know the value for x is equals to pi by 2. So what will I do is, I'll have to find the value for y also, isn't it? So what will I do then? With the value for x equals to pi by 2, put the value for x equals to pi by 2 out here, which gives you the value for y. Okay, so sine square pi by 2 means sine pi by 2 means what? 90. Sine 90 is 1. So 1 square is 1. So what is the required point? The required point out here is pi by 2 comma 1. So at this point I need to find the equation of a tangent. Okay, so equation of a tangent at which point? At point P, pi by 2 comma 1. Same formula, y minus y1, which is equals to dy by dx, x minus x1. So y minus y1. What is the value for y1? 1. What is the value for dy by dx? 0. And then x minus x1 is pi by 2. So 0 into any number is 0. So hence the equation of a tangent will be given by y minus 1 is equals to 0 only. Okay. So pause the video for note down. We move to another sub part of this question, that is find the equation of a normal as well, isn't it? So equation of a normal. So equation of a normal at which point? At the same point, pi by 2 comma 1. The formula is same, y minus y1 is equals to minus 1 divided by dy by dx, x minus x1. x1 is 1, x1 is pi by 2, y1 is 1. So y minus 1 is equals to minus 1 divided by 0, isn't it or not? 1 divided by 0, because dy by dx, the value for dy by dx is 0, x1. Now don't put the value for 1 minus 1 as infinity, because if you do infinity, then you will not be getting equation of normal. But instead of that, what will I do is I'll cross multiply with 0. Okay, so 0 into y minus 1 will be 0, and which is minus of x minus pi by 2. Then you simplify it, then we get the equation as, just do multiply with 0, the left hand side becomes 0, and simplify the right hand side, then we get the equation of normal. So pause the video to note down. So I hope you have got some idea about how to find the equation of a tangent. So once again I'm repeating, whenever we need to find the equation of tangent, we need to know the slope of tangent and the required point. If these two things are known to me, then we just need to put in the formula. Y minus y1 is equals to dy by dx, x minus x1. Okay, so x1 comma y1 is important and slope is important to find the equation of tangent. Okay, let's take another question, number 15. Find the equation of a normal. In this case, I need to find the equation of normal to the curve, this curve given to us. So e into y square is equals to x cube. This is the curve given to us, and we need to find equation of a normal at em square comma em cube, isn't it? So what will I do? Start with y. So y square equals to x cube by a. Okay, then differentiate it. Once you differentiate, then we will be getting the value for dy by dx, isn't it? Which is the slope. Now, slope at which point? Slope at this point will be this much. Just put the values, cancel it, you'll understand. This is basic, simple algebra, mathematics. Okay, we will be understanding. Nothing much important. So, differentiation, put the values, then you'll get slope of tangent. Once you get the slope of tangent, we know what to do. What am I finding, by the way? I'm finding equation of normal. So if I'm finding equation of normal, then slope of normal I need to find. The formula to find slope of normal is minus 1 divided by dy by dx, which is equals to minus 1 divided by dy by dx. So what is the value for dy by dx? 3m by 2. So minus 1 divided by dy by dx will be minus 2 by 3m. So I hope you're clear with slope of normal. Pause the video to note down. Okay. Slope of tangent and then slope of normal. Now, with slope of normal, as this, the value for x1, y1 known to me. So can I find equation of normal? Yes. So equation of normal will be out here. Okay. Yeah, equation of normal. So equation of normal at which point? At am square comma am cube. So we need to find equation of normal at this point. So the formula y minus y1 is equals to slope of normal into x minus x1. This is the value for x1, this is the value for y1. So put the value accordingly. x1 is this and y1 is this. This is just what we have found out here, isn't it? Slope of normal minus 2 by 3m. So I'm replacing the same value out here, minus 2 by 3m slope of normal. You know what to do, cross multiply with 3m and then multiply with minus 2. Bring everything to the one side, in the left hand side, okay, or right hand side, then you get the final answer as this. I hope you can verify this yourself. So pause the video to note down. So this is your question number 15. Okay, now 15 is done. I want you all to try question number 17, which is given in parametric form, and the parameter out here is t. 17 part 1 and part 2 I'll be giving as assignment, and I'm now straight away jumping to question number 20. Okay. Question number 20. Now let us read and understand question number 20. Find the equation of a tangent to the curve this which is parallel to this. I'm just doing number 1 first and then I'll explain number 2 also. Okay. So find the equation of a tangent to the curve this. Now let us understand the figure as well. Find the equation of a tangent. Okay. This is the curve given to us. I've written y is equals to x square minus 2x plus 7. There is a curve given to us and we know that on this curve I'm taking a point P where I'm drawing a tangent. So hence this is my tangent. And remember, I'm finding equation of a tangent to this curve. At which point? At P. Another thing given to us is I need to find the equation of a tangent where this tangent is parallel with the straight line. 2x minus y plus 9 equals to 0. I hope you're clear now. This is the tangent which is parallel with this line, and we know that if two lines are parallel to each other, slope of these two lines are equal. So slope of tangent and slope of this line will be equal. Okay, now how will I find the slope of tangent? Differentiate, not a problem. Differentiate with x, I'll get the value for dy by dx. How will I find the slope of this line? Please make it into y equals to mx plus c form. Okay, we'll transfer this equation into y is equals to mx plus c from where we'll get the value for m. So that will give me the slope of line. Slope of tangent dy by dx. Since it is slope which are equal, so I can equate, and while equating we'll get the value for x. Put the value for y in equation of curve. That will give me the value for y as well. So I'll get the slope, I'll get the required points, then hence I'll also find the equation of tangent in this way. Okay, so let us start. So now, as we are clear with the question, curve is there, whose equation is this. On this curve I am taking point P and I am drawing a tangent at this point. So this tangent and this line is parallel to each other. So let's quickly start with our slope of tangent. So slope of tangent is 2x minus 2, not a big deal. Given line is this. This is the given line. Transform into y equals to mx plus c form. So which will give you y is equal to 2x plus 9. And from here, what is my slope? Slope is 2. Okay. Now one thing. Again in the question is given that the tangent is parallel to the line. Now as the tangent is parallel to line, so slope of tangent will be equal to slope of line. Slope of tangent 2x minus 2. Slope of line 2. Okay. On solving, you'll get x is equals to 2. Any problem? I hope you're clear with this. Now, put the value for x equals to 2 in this curve. Remember that my point is out here. My point is not here. So don't make a mistake of putting the value of x out here. Okay, my point is here. So hence I have to put the value for x out here. Okay, please be careful with that. Students often make a mistake with this. Okay, so putting x equals to 2, or putting the value for x equals to 2 in this curve. Okay, which is this. So once you put the value, just simplify it. 2 square is 4, 2 into 2 is 4, 4 gets cancelled out, so y equals to 7. So what is my required point? My required point is 2, 7. Okay, 2, 7. I also got the slope. So hence, I can write now as this line. So equation of a tangent at 2, 7, which is parallel to line having slope equals to 2. Okay, because what is the slope of this line? What is the slope of this line? 2. If the slope of this line is 2, then slope of the tangent will also be 2. I hope you're clear. And what am I finding? I'm finding equation of the tangent. So therefore, equation of a tangent at this point, which is parallel to the line having slope equals to 2, is given by y minus y1 into slope is equal to slope into x minus x1. Now what are the values for x1 and y1? x1 is 2 and y1 is 7. Put the value, simplified. Hence I get this equation of tangent. So pause the video for note down. Now in question number 20 part 2, there's a bit twist. Okay, we need to understand the twist. Okay, find the equation of a tangent to the same curve. The curve is same. Okay, but one thing is given, that equation of tangent, that tangent is perpendicular to the line 5y minus 15x is equals to 3. So all in all, if I draw the figure, if this is my tangent, okay, this is the same curve, then another line is there which is perpendicular. Okay, are you understanding? But in this case also I have to find the equation of a tangent on the same curve. Find the equation of tangent on the same curve where this tangent is perpendicular to this line whose equation is given to us. So we know that when two lines are perpendicular, slope of this line and slope of tangent, the product equals to minus 1, isn't it? So let's start with the solution. Okay, now so this is the given line 5y minus 15x equals to 3, and from here please take it in the form of y is equals to mx plus c. On doing so, I'll be getting the slope of the line, isn't it or not? Slope of line equals to 3. Now what is the slope of tangent? The same, the curve is same, so slope of tangent is also same, and we know that if two lines are perpendicular to each other, the product of the slopes equals to minus 1. So 2x minus 2 into 3 is equals to minus 1. 2x minus 2 is slope of the tangent, and slope of the line is 3, so it is minus 1. Okay, you simplify it, you'll get the value for x, which is 5 by 6. Now another thing which I know, which you need to note out here, why did I told you the question is a bit twist out here? Because slope of the tangent I need to find. Please remember that I'm finding slope of the tangent. When I find the equation of tangent, I need to know the value for slope of tangent. And what is the slope of tangent? 2x minus 2. Now from this equation also, only 2x minus 2, the value for 2x minus 2 will be minus 1 by 3. If I take this 3 to the right hand side, 2x minus 2 will be minus 1 by 3. So which also gives me the slope of tangent, isn't it or not? Please remember the value for slope of tangent, which is minus 1 by 3. Okay, because slope of tangent is what? dy by dx, which is equal to 2x minus 2. And what is the value for 2x minus 2? Minus 1 by 3, which is this, because this is the value for dy by dx. Okay, now with the value for x equals to 5 by 6, I'll put this value in the curve again, which is this curve. Put the value for x. Once you put the value for x as 5 by 6, simplify it, you'll get the value for y, which is another point. So hence the required point is 5 by 6, 217 by 36. Okay, so therefore I can find the equation for tangent. Equation for tangent is given by y minus y1 is equal to slope of the tangent. It was perpendicular, we have done everything out here, minus 1 by 3, so simplify it. Okay, wherever you want to take the LCM, cancel out, you can do, and then cross multiplication, and then finally verify your answer will be as this much. Okay, so pause the video to note down. So that's it for today, and then tomorrow we will finish this exercise as well, and then we'll start another one. Okay, by the way, your assignments will be, let's pause the video for a while. So please note down your assignments for today. This is assignment number 7 18th of May, 17 part 1 part 2, 14 part 2 part 3, and 21 part 1 and part 2. Please do follow the videos properly. Okay, wherever you want to pause it. When you want to rewind it. Okay, and then try to understand. There are plenty of examples done in your book as well. Do follow the examples and then practice it regularly. Okay.